All right, 2-2 logic statements. Some different types of stuff today, but stuff that I think you'd be successful with. Pay attention to your definitions. Make sure that you understand what each of the bold words means, and we can move through this. All right, so today we're going to be looking at determining truth values and really what that means for different statements. It might be a math statement. It might not be. All right. But basically, we're going to look at a statement as a sentence that's either true or false, and so we're going to determine the truth value based on if that statement is true or false, okay? A lot of times here, you're going to see a statement represented using a letter. So the one they talk about up here is they say, hey, let's say we had statement P, Chicago is a city in Illinois. Then you could look at that statement and see if it's true or false. Obviously, Chicago is a city in Illinois, so the truth value of that statement or statement P is true. All right, so let's get into some terminology. We can have the negation of a statement, and for our intents and purposes, from an English perspective, it's pretty much like the opposite of that statement. All right, so this is read as not P, all right, and it's the negation of statement P. So like the negation of this statement up here would be that Chicago is not a city in Illinois. Well, we know that that's false, but that would be the negation of that statement. All right, the two types of compound statements that we had, that statements joined together, and it can be two or more. All right, we have a conjunction, and those things are joined with the word and. The symbol for that is like the little caret that you use in English, or little rooftop, or little exponent button that some of you use on your computers. And then we have disjunctions, which is, again, a couple of statements or two or more statements, and it's joined by the word or. And then we use a little upside down B for that. All right, so let's jump down here into these examples. All right. So in example 1, they want us to write compound statements, all right, for each conjunction. Now you can see the symbols are the little caret or the rooftop. So we're using the word and. Statement P is an elephant is a mammal. Statement Q is a square has 4 right angles. All right, so let's walk through it. Here's how to write a conjunction of those. All right, we would take statement P, which says an elephant is a mammal. We put the word and in between it and then write a square has 4 right angles. So there's P and Q. Now we got to look at that and see if it's true. Is an elephant a mammal? Of course it is. Does a square have 4 right angles? Of course it does. So that makes both parts of that statement, or both individual statements, when they join together with the word and, are true. So the whole thing is true. We just write true and we roll on. Now look at this. They want us to rewrite the conjunction with the negation of P. So that's taking statement P right here, an elephant is a mammal, and negating it, saying an elephant is not a mammal. All right, so here we go. We're going to write it out. We're going to do the negation of P and Q. An elephant is not a mammal, and a square has 4 right angles. That sentence is fine. Doesn't matter if it's true or false. We can write it that way. Now, when we look at it, for a conjunction to be true, both or all your statements have to be true. Well, when you look at an elephant is not a mammal, that is false. So since that is false, we say the whole thing is false. All right, now look at disjunctions. Okay, this is the V. We call that an or statement. So we're going to write, in this instance, our 2 statements and make a compound statement using the word or. All right, so statement P here is a diameter of a circle is twice the radius. Statement Q is a rectangle has 4 equal sides. And again, right now it has no bearing on how we write these if those statements are true or false. All right, so example 2A says statement P or statement Q. We're going to write out our compound statement. All right, here we go. A diameter of a circle is twice the radius. That's statement P. Or a rectangle has 4 equal sides. That would be statement Q. So that's how you write an or statement. Super easy. Now, for an or statement to be true, only part of it has to be true. So if we look at it, a diameter of a circle is twice the radius. That's true. So the whole thing is true. Even though a rectangle has 4 equal sides, that's false. But for a disjunction, only part of it has to be true for the whole thing to be true. So part A is true. Part B, the negation of P or Q. All right, here we go. Now I'm going to take statement P and negate it. What's that going to look like? A diameter of a circle is not twice the radius. All right, or, and then statement Q, a rectangle has 4 equal sides. So now in a disjunction, I've got to look at the truth values of each statement. A diameter of a circle is not twice the radius. That is false because a diameter is twice the radius. Or a rectangle has 4 equal sides. A rectangle does not have 4 equal sides. So since both of our statements in our compound statement are false, the whole thing is false. That's how it works. All right, I'll jump down here. You can write this down. This is pretty simple. This might even be something to practice, maybe cover up what I've done and practice it on your own. So they give us 3 statements, and they want us to write some different compound statements and find the truth value. All right, here we go. Got a conjunction. P and Q. Here we go. So P is 10 plus 8 equals 18. My conjunction is and. September has 30 days. When I look at the truth value in an and statement, both of them have to be true. Is 10 plus 8 18? Yes. Does September have 30 days? Yes. So the whole thing is true. All right, let's go down to number 2. An or statement, P or R. Remember your truth values. When we do our compound statement, if it's or, only one part of it has to be true. Here we go, statement P, 10 plus 8 is 18, or a rectangle has 4 sides. Now, both of those happen to be true, but since one of them is true, we can look at, hey, 10 plus 8 is 18 is true. It's an or statement. The whole thing is true. All right, number 3, Q or R. Again, another disjunction. Only one has to be true. Q is September has 30 days, or a rectangle has 4 sides. One of them has to be true for the whole thing to be true. Well, September has 30 days, so it's true. Now, a rectangle has 4 sides is also true, but we didn't even really need to get there. All right, number 4. Q and the negation of R. So we need to write the negation of R and then write our compound statement conjoining Q and the negation of R. Here we go. Q is September has 30 days and a rectangle doesn't have 4 sides. For a conjunction to be true, both have to be true. September does have 30 days, but a rectangle doesn't have 4 sides. That's false. So the whole thing is false. That's kind of how that plays. All right, constructing truth tables on the back. A little bit weird. It walks you through up here what negations and conjunctions and disjunctions look like. I do it a little bit different than the book. You can do it this way. All right. I'm going to write a disjunction for Q or R. So basically, here's how it works. You've got to think about a statement Q and a statement R, kind of like what we're doing on the front page. And you got to look at it this way. Both statements could be true. If both of them are true, the disjunction is true because only one of them has to be true. Statement Q could be true or statement R could be false. Well, if one of them's true, the whole thing is true. So Q or R is still true. Statement Q could be false, but statement R could be true. Again, if one of them is true, the whole thing is true. So Q or R, the compound statement is true. Now look here. If Q is false and R is false, when I look at Q or R and they're both false, the whole thing is false. And you can kind of see that table play anytime we have an or statement. And I'm only going to give you 2 variables, and I'm not going to make you write your negations any other way. So you're going to see that a little bit differently in different spots of these notes, but it's going to be fine. Again, so here we have P or R. P can be true, R can be true. Well, if one of them is true, P or R is true. P is true, R could be false. Well, P or R, if one is true, it's true. P can be false, R could be true. If one of them is true, the disjunction is true. P could be false, R could be false. If they're both false, then the disjunction is false. All right, look at a conjunction now. Go to number 3. Look at Q and the negation of R. And again, this isn't necessarily how to do it, but it works for what we're doing. So statement Q could be true, the negation of R could be true. In a conjunction, if both are true, then the conjunction is true. That's the only one that works that way. Q could be true, negation of R could be false. They're not both true, so the conjunction is false. Q could be false, negation of R could be true. One of them is false, so the conjunction can't be true. And obviously, if both of them are false, the conjunction is false, and you can see, same type deal. The way that I set up tables is a little bit different than the book, but I think it gets the point across, and I think it's something that you can do well. Check your assignments. Try to get this one going with a little Google slides. So click on 2 skills. You should be able to fill in your stuff right there. Do not do numbers 7 and 8. I believe it's the one where your truth tables had more than one variable. Thank you.